In this video we're going to look at example 1, but before we do that we're going to learn two facts about probabilities. So the first fact you probably already know. If we've got an event A which has probability 0.4, if we want to work out the probability of not A, so A dashed, we can do 1 minus the probability of A. And that's because we know that the sample space adds up to 1. So we want to work out the probability of not being in the A circle. So we know that that probability must be 0.6. So in this example we would do probability of A dashed is 1 minus 0.4, which is 0.6. And that's basically using the fact that probabilities add up to 1. In words, you could write that as the probability of not A is 1 minus the probability of A. We also need to know what the word independence means. So we're going to learn the definition, and then in another video we're going to look in a little bit more detail when we look at conditional probability what independence actually means. But for now we need to know if A and B are independent, then we know that if you want to work out the probability of A and B happening, then we could times together the two probabilities. Now, you will already know this fact, but you might not have spent much time thinking about why you can use this fact. And it turns out that you can only use this fact if the two events are independent. So just looking at this Venn diagram, we've got two independent events A and B. To prove that they are independent, we would work out the probability of A and times it by the probability of B. So the probability of A is, in total, the probability of being in the A category is 0.1, times by the probability of being in the B category, or the B event happening, is 0.2. And if we times them together, we get 0.02. And that is equal to the probability of A and B. So we could say, because the probability of A and B being in the middle of the Venn diagram, the intersection, is equal to the probability of A times by the probability of B, we could say A and B are independent. And we'll look a little bit more about that topic in another video. So in example 1 we've got a pack of 52 cards and we're selecting a card at random from the pack. So let's draw ourselves a Venn diagram to help us think about this situation. So we've got a circle for aces, picking a card that's an ace, and we've got a circle for picking a card that's a diamond. And we've got an overlap because we know that in a deck of 52 cards there's a 1 diamond that's also an ace. Now you should know that in a pack of cards there's overall 4 aces, only one of them's a diamond, 3 of them are from the other suit. And you should also know that there's 13 of each suit in a pack, so there's 13 diamonds overall, only one of them's an ace, so there's 12 that are other than an ace. Obviously 1 to 10, and then the jack, queen and king. 1 to 9, sorry. And then we can work out what's on the outside of these two circles, because so far we've got 16 cards. So we know that on the outside there must be 36 cards that are not in either of these sets, that are not aces and also not diamonds. So in part A we're asked to find the probability of A and B and D happening. So that's the probability that we pick a card that's both an ace and we pick a card that's a diamond. So we can see from our diagram that there's only one card that's an ace and a diamond, and it's one card out of 52, so the probability is 1/52th. In B, we want the probability of A or D happening. So that means we pick a card that's in the A set or in the D set. And remember, this includes those cards that are in both of the sets. The card just needs to be in one of these categories. So we can see from our Venn diagram that overall we've got 12 add 1 add 3 cards which are in at least one of those categories, A or D. So we've got 16 cards out of 52. In C, we're asked for the probability of A dashed. Now remember, A dashed means the probability of not picking a card that's not in the A set. So a card that's not an ace. So one way of doing this would be to count up all the cards that are outside of the A circle, the cards that aren't aces. So we've got 36 plus 12, which is 48 cards out of 52. Well, another way of doing this, working out the probability of A not happening, would be to use the fact that we learned before, that we can do 1 minus the probability of A happening. So let's write that down. The probability of A not happening is 1 minus the probability of A happening. Or in this case, the probability of A happening, the probability of picking an ace, is 4/52ths. And that's equivalent to doing 52/52ths minus 4/52ths. And we get the same answer of 48/52ths. And here we've basically done 52 cards, take away the 4 aces, and that's going to be the probability of not getting an ace, because there's 48 cards that aren't aces. And then for part D, we're asked for the probability of not A happening, so A not happening, and we want D to happen. So this means that we're going to pick a card that's not an ace, but also it's a diamond. So we can look at the Venn diagram to help us out here. Not A are the categories that are outside of the A circle, so that we're left with these two categories. But we also want it to be a diamond. So not an A and also a diamond must mean that we're picking one of these 12 cards here. So it's 12/52ths. Equivalently, you could think about that as picking a diamond that's not an ace, and there's 12 diamonds that aren't an ace.